Alright, another DraftScience video presentation. Yeah, I'm here, you're here, so might as well get on to it. So paraplegic, something like that. Edit. It's an edit. Ooh, this comment was meant to refer to the video released previous to this one. Okay, doesn't really matter, they're all the same. It's still like to hear your thoughts, though. I don't know why you didn't. If you're going to edit the comment, just delete it and post it on the other video, but it's okay. It doesn't matter. Here's a thought experiment problem that occurred to me when listening to this. Yeah, well, that's unfortunate because it sort of means that you're missing some parts of the story. Yeah, so I guess I'll do one part of the story. Oh, sticky. Something. Anyway, well, I guess I'll wait until you say your stuff. All right, imagine you have a rocket in space, but rather than ejecting its exhaust out into open space, there's a very long cylindrical container, like a test tube or something, I guess, very long one, attached to the back of the rocket that collects the exhaust gas. It's like putting a sail in front of a sail or something. That isn't going to work. But anyway, presumably that exhaust gas would reach equilibrium. Why presumably? Why wouldn't it go for a very long time in space, right? We're in space now. But even if it didn't, let's say it was in an atmosphere and it could lose its equilibrium. Let's just say that for example. Within the secondary container sometime after being ejected. Right, but that means it's pressurizing the secondary container gas, repressurizing it. It's changing the environment in the container and changing it back into a pressurized gas. After being ejected, then it would have equal momentum in all directions. No, it's going to have more momentum in one direction, the direction you're pressurizing it, like any volume of gas does. Could you then re-eject that gas and use it to gain even more momentum? Well, see, I mean, it is a little bit, you have to think about it and say, well, why doesn't this make sense? There's got to be you can't reuse it. That just doesn't make any sense. And then repeat that process ad infinitum. Yeah. Okay. Alright, so let's finish it. To me, this seems troubling that the gas molecules themselves don't lose any energy individually when being released from the rocket. Yeah, well, they really do. See, that's the trick. In terms of the force between them. See, again, I'm sort of arguing that drag really is something that exists in the universe. That the little bits do get dragged to a halt. It's the big atoms that don't. Okay, it's the atoms that can overcome moving into pressure. Okay, seems like the conflict with Newton's third law. Well, the conflict with Newton's third law is the very idea that the equal and opposite force comes from the environment. When, as I explained, the equal and opposite force comes from the fact that you gave away a force and now broke your own equilibrium. You had equilibrium. You gave a force to somebody. Now you have a disequilibrium. That's the only opposite force. Then an object will not accelerate without the influence of an external force. So again, blah, 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 blah. So like the bowling pin analogy, I've sort of trying to point out, the analogy of the pins going in a straight line and you're keeping the energy in a direction. And if you can keep the energy moving in a direction, it's still what we would call energy. And it's not until you turn into heat or something that you make it into something that's not so... It's still energy, but obviously we know it's hard to turn heat into, a laser beam. It's hard to turn scattered light into focused light. So that's the trick of it. But let's go through it and see where we go. Because, yes, there's some likelihood that you can't reuse the energy to propel yourself because you have to be connected to the object that's getting pressurized. And in the process of being pressurized is where you're going to lose it all. So the first thing to understand is these rockets are a little more complicated than what you're explaining. Okay, you're thinking, okay, it's just pressurized gas and I just let a pressurized gas out. But that's not really what you're doing, right? So there's two parts to this thing. Yeah, there's the containers that are pressurized, of oxygen and hydrogen. And so you're releasing the pressure of the gas, but that's really not the only thing you're doing, right? So when you're mixing the two, then you're igniting them. The fact is that that's you're getting two effects. So you have the one effect of, yes, you have pressure, gas pressure leaving, but then you have this other effect that the whole nozzle's for, which is you're going to light this stuff, and then the atoms are going to go from being little atoms to being big atoms. Okay, so you're going to go from hydrogen and oxygen, and you're going to be making big water. Okay. And in that process, you're doing all this expanding. And so there's a great deal of pressure when these molecules expand. And when they expand also, they're releasing all this heat. So they're releasing a bunch of the little bits, the very small bits. So I don't know how to draw all those little things. I guess I could just put little dots here. So, you're not only making something bigger, but you're making little fast bits flying off of it, little photony kind of bits. So when that's happening inside the nozzle, and the whole point is the nozzle sort of, as it looks, it's sort of saying, I want the energy to have no choice but to give some component. When it does that expanding, I want to be able to steal from the, say the explosion is round. You want to steal from the round explosion anything that has a vector in this direction. So anything moving in this way or that way or this way, you want to try to steal it and force it to cause motion in this direction. So you make a nozzle, with that kind of shape, and that way any direction that this expansion's happening except this way, okay, you're going to essentially take advantage of that in the sense that it's going to push on the nozzle and the nozzle is going to push on the spaceship. So you're not only ejecting this stuff going very fast this way, but you're also, getting your half of the spring. I mean, in a sense, the well, whatever. There's no other way to say it, really. You're causing stuff to hit you, okay, which will cause the nozzle to expand. And since it can't expand, the energy has to push it this way, because you're essentially causing a reflection, okay, and the reflection is going to be part of the energy you're releasing. I guess that's a better way to say it. So all the stuff that's going this way reflects and ends up going out the nozzle. Going this way, it reflects, goes end up out the nozzle. So you're not only sending the stuff that goes straight out the nozzle, but now you're sending the stuff expanding. You're sending the stuff going in this direction also out the nozzle. So you have a bunch of different size stuff, big molecules going not so fast, but fast. And then you got all the little bits tied to it. Lots of little bits going very fast. So you got all kinds of momentum, that you're shooting out. So that's not really what you're describing. Now, if you collected that, theoretically this stuff is going in space. It's not really hitting anything. So it still has all of its pressure. And so if you create a vessel, a bag to catch it, the point would be is that it's going to hit this surface, okay, with the same kind of energy that pushed the rocket. And so, that's where you're dead. It's because now you're just going to create motion in this direction. Now, this is a really interesting experiment. As I've pointed out, it's too bad NASA and such. Oh, I probably have to find my eraser. Yeah, I probably have to do that. Yeah, okay. I should have this angle better, frankly. Yeah, like that. Well, then it's got glare on it. Alright, so you have to stick with that angle. Okay, so, yeah, so that's probably enough of a start, and then we'll just redraw it with just, say if you were using one of these little navigating kind of things that just shoot the pressurized gas out. I think that's more likely what you were talking about. Because this, really no chance. I mean, if I attach this to the spaceship, okay, this bag. It doesn't really matter how long I make it because there's empty space in there. And even if there was an empty space, if I'm pulling a bunch of matter, okay, then my ship is a lot heavier and I'm getting a lot less out of it, and it's still going to hit the matter. I mean, it's still going to hit the matter at the bottom of the bag. So it just doesn't matter. I'm still going to be hitting matter the wrong way that's connected to my ship, and so I'm just defeating my purpose. The momentum can't go away for free, is the point. This stuff won't reach equilibrium because it's just will. It has to actually hit something, and by hitting something, it's hitting something that maybe wasn't going to ever hit anything. You know, something going this way. And now that something going this way won't go this way because you've hit it this way. So you're essentially killing all the natural equilibrium that would be in the environment. If there was any, you'd be absorbing all of it by throwing stuff down at it. And so now you're reflecting it. And you're going to cause it to cause more pressure down this way. And all of that pressure is just going to undo what you're trying to accomplish. In a sense, you're just making your pressurized container bigger, and you're not releasing your gas. Okay, so if you put this on, you're just collecting your pressure again, and so you can't gain anything, theoretically. Yeah. Alright, so I'll pause for a second and clean up. Alright, I'm back. Alright, so same scenario, we just make a different ship. Yeah, ship that doesn't, just navigates by shooting a gas out the sides or whatever. Something like that. Anyway, so if I shoot a gas out, and so I've done the thing, I've released pressure, so I have stuff going in this direction. So it's like, what do you call those things? A fire extinguisher. Like in the movie Gravity, right? You move around with a fire extinguisher. Okay, so you have a tank of compressed pressure, okay, where you got lots of pressure, and you just let some of it out in a direction, and that moves you in the opposite direction because you have equilibrium because it's a pressurized tank. It's bouncing on all the surfaces. You let it go out one surface, well then the other surface is still hitting over here, the pressure. And so you have an imbalance, and you go in the opposite direction. So if I put attach a bag onto that, you can just sort of get that. What am I going to accomplish? It's just going to take the pressure, bang it off this wall, so I'm right back to the tank again. I might as well not have a hole in the tank because I've now caught pressure, and so I'm going to have hit this way, and I'm going to have a hit this way. I'm going to be back to equilibrium. So it just really, realistically, you can't gain anything. So you could do it, gain a little bit, while it's moving through the bag, till it hits the opposite wall, and then what happens? So you go this way, and then you hit the opposite wall, and you go back this way. So you still won't gain anything. You just do this kind of motion. So that's something I was trying to get to, in earlier videos. These would be interesting experiments to see inside the space station thingy. Because this is the kind of stuff you can do when they probably should do it when the ship is, I guess they never decompress it, It's made to always be under compression in that, the place where they go in and out of the ship, what do you call that? What do you call that? You have the ship, and then you have a place where you can do your, where you go in from here, and then you go into the pressure here, so you can, take all the air out of here and put all the air back in again. Well, anyway, inside of there would be the place to do it, or just do it out in space. So the idea would be is to create a mechanism like you're describing, except just, anything that's connected and has two surfaces, and you throw some energy in, okay, to the two surfaces. So ideally it would be more like this, like you just have two surfaces, connected surfaces. And, if you have a little gun in here and you just fire something this way, you know, like a ping pong ball. And just watch this event take place, which is, okay, you fired it, and so let's say the gun's not likely to hit the ball, so just try to make the gun, you know, shoot it and then take the gun out so it can go back and forth without any interruptions. And the idea would be is it hits this surface and it gives it momentum, you know, and then it goes, this object moves, and then it reflects back, and then it's this surface that's now here because you're moving, right? So you go less distance this way. You know, the ball travels less distance because this surface moved that way, you know, and now your surface is stopped. Okay, so you were moving, going, I don't know how to best describe that, how to best draw it. Okay, so when you initially go, you start the thing moving this way, right? And now the back end will be here when this ball hits here. And what is that going to do? That's going to just stop you. It's not going to make you go the opposite direction because it's the same energy that moved you this way. So here you stop, right? You know, and now the ball will reflect off that new surface, and now your front surface is over here because you did move before you stopped. And so now the ball travels the full distance, okay, because you're stopped, right? So this one goes the full distance, and it starts you again. And so now you'll move to this new position, right, eventually, and you'll be here. And then the ball's going back while you're moving. It hits the surface and stops you again. So we would see it actually pulse. So we're already seeing order out of disorder in the sense that you just shot something and it's turned it into a frequency. I mean, that's how easy it is to make a frequency in nature. Is all I have to do is put energy into a system that has a size, and the energy will take care of creating the pulse. And you know, so all you have to do is have a matter analogy for this. But I mean, I wish they'd done it. I mean, I don't know if, you know, I haven't watched all of the little childish experiments they do on the space station, frankly. I mean, it's all made to be some sort of educational program. There's no real physics that they ever do, which is very disappointing. Like, everybody has a proprietary, you know, it's like, you know, the institutions pay NASA to put their crap on the space station, so they all have copyrights to all the data and information. It's just such a dismal, you know, how science is just, you know, corporate property now. But anyway, so this is something they could do, though, pretty simple. They might even just be able to, you know, take a little box with a BB in it, you know, and just shake it and then let it go. And the last way they shook is going to be the way the box just keeps going. It'll just keep pulsing in that direction. Interesting experiment, anyway. That we'll never see, I guess. But anyway, so that's sort of what I'm... Look, there's two things that the energy can do, as I've pointed out. The energy, say the electron and the proton, are affected by two subtly different pieces of the force, so I don't want to get into that. But I mean, the idea is that either it reflects immediately, like as soon as it hits, it reflects, or it pushes something for a while, okay, and then inevitably reflects, because after pushing it, it's inevitably going to hit something going the opposite way. Oh, can you see that? No, you can't. Or yes, you can. Yeah, it hit something going the opposite way. See, I'm here. You know, and you know, a little bit of force hits it from the other way, and that means this thing reflects, and it means this force reflects. And so, you know, you end up with this not moving anymore until the next thing pushes it. And then it goes that way until something stops it. So the idea is that force is not continuous as soon as it's interacting with matter, because it goes from going in a direction to stopping, then going in a direction and stopping, then going in a direction and stopping, then going in a direction and stopping. Yeah, that's how I should do it. Going in a direction and stopping, going in a direction and stopping. So, you know, that's probably the nature of why there's Brownian motion, why there's this, that, all that stuff is being caused, not because the things have continuous motion. It's because they are constantly being interacting with different forces in different amounts from different directions. But the idea is you're either pushing or you're reflecting. You don't do anything else. You either push it, that means you go slower as a force bit, you move slower in the universe because you're pushing, or you just reflect. And that's it. Okay, so I guess we're done. Yeah, I'll see if there's anything else that's worth saying, but I doubt it. I tend to doubt it. Yeah. Alright, should be back. So the rest of the somebody else commented, do you want to ask this to Puro and Numbly Num? I don't know where Numbly Num is. I haven't seen him in 2 years or whatever it is. Maybe he's going by some other name now. But anyway, probably just like I said, another petty troll. I mean, you know, my argument with Numbly Num is based on the fact that he just became a conspiracy theorist, and you know, I abhor conspiracy theories. I hate them. It just makes noise. It's just scapegoating. You know, instead of getting to the truth, people are just getting distracted by bullshit. And that's very, very destructive to any kind of useful engagement, brain on brain kind of thing. So I guess I could just do tiny bit of overview commentary on what's needed here is more conversation. There has to be more people willing to make videos on these subjects, and there just aren't, and that's the unfortunate fact. So these elemental functions like Newton's laws and stuff, this isn't what the dissidents play with. They seem quite obsessed with magnetism, which makes some sense, and light and little ferrocell gimmicks and all of that crap. And that's the unfortunate part. They keep looking for this free energy crap, which, you know, it's all like agenda physics. It's not, you know, we need light speed, so I'm going to invent it because we need it. Yeah, well, good luck with that. Not very good science. There might be something else in this comments I could do something with. I perfectly agree with Gary. Well, whatever. So what? I'm just saying it's not an argument of any kind to just say, in my opinion, you're a jerk, or in my opinion, you're God. And neither one of those help any. Okay, we already did the breaking the equal rhythm. I'm not blocked. We already did that. I thought that was up higher, frankly. But anyway, it doesn't really matter. Let me see if there's anything in here. Everything which is something most people, if we were to realize that matter is a collection of forces, you know, that's the part where you got to be a little bit careful. Matter is matter. I mean, in a sense, the electrons are electrons, and they aren't doing anything themselves. They're just victims of the forces they're in, and that's it. Alright, I guess I'm not blocked. Oh yeah, we did that, sorry. Must be, okay, so, kilojoules, question marks. That must be an unreal amount of force. Well, I don't think you were paying much attention. I was just saying that, you know, we have a lack of appreciation for how much energy is actually in electricity. You know, it's really a cheap, you know, and a lot of energy. And, no, so it gets to like kilowatts isn't very much. Okay, I'm just arguing it's a lot. So no one should say that's not very much energy. Well, it's a lot of energy. I mean, you can roll lots of bowling balls and shoot lots of bullets and all of that kind of crap. It's a lot of energy. But yes, compared to what we use in one day, not so much. All right. This was a weird comment, as I recall. I was the #1 viewer on this video. Wow, that's somehow important. It never happens, though. Well, it's pretty easy on this channel. I do it all the time. Okay. All right. So I agree with you, your sentiment on photons not really being quanta. Yes, a photon is a composite object. It's made of quanta. It's not the quanta itself. All right. In my opinion, photons are continuous analog of momentum transfer through the medium. And of course, I just totally see no point of this medium. How does the medium work? How does the medium make straight lines? Blah, 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 blah. Why you people have to believe in dominoes, I don't understand. The domino still has to move, you know. I mean, even if you have a medium, you know, how does it bang into itself? And what's between the little bits of medium? And, you know, you just get into trouble. I mean, you can understand it as real physics by saying, okay, I understand Jello is molecules that are stuck to each other. You know, they're sharing electrons, but not very strongly. Okay? And so you can understand how whole masses of it can move around and all that kind of stuff. But you know there's still empty space between the atoms. You know there's empty space in the Jello. You know, you do this medium thing, and you're just breaking the whole concept of movement, because to bang into something, you gotta move something, and what's it moving into? Itself? I mean, you know, I don't know. It doesn't work for me. And the perceived motion thereof associated. Well, those were extra words I didn't need. Photons are abstraction. Man, screw that. For the transfer of stress through the medium. So again, stress formed in what way? You know, I mean, it expands and it contracts, and, you know, then it's creating motion in all kinds of directions. If I take a rod of some kind and I make it short and I make it fat and I make it long and I make it thin, then it's creating a whole bunch of movement in all these other directions. And there's no evidence photons are doing any of that kind of stuff. All right, so there are quanta only at the level of the granularity of the medium. So again, you're just, well, what's the point? You want to argue the existence of ether. You have no evidence. I don't have any evidence saying it can't exist. I mean, I'm looking at ether as just being a God theory, right? You're saying there is a something, and I'm saying, well, why do I need the something? The mechanics works without the something, so why do I need it? What role is it playing? Your dominoes still have to have momentum to knock each other over. I mean, what are you changing? All right, which antithesis like me, or whatever this is, entheists, I don't know what that is. Oh, etherists. Oh, like me. Yeah, I don't know the word because it's, you know, you're just talking foreign gibber to me. Which etherists like me call ether. Oh, okay. From the perspective of what usually matters, i.e. bits of matter, electrons, etc., there is no quanta to speak of other than just the medium's granularity. And again, where's your straight line vectors? How do you make something go in a straight line? I'm just saying there's no geometry for a granular ether, because straight lines are impossible. You just end up scattering everything over distance. Yes, many people are less than sophisticated, and many are not very intelligent. What I was a younger man, an old Italian gent, corrected my generalizations about some subjects we are talking about. The intelligence of people, of course, follows the bell curve, the normal curve. There's no underlying mechanics to that, and that curve can be very narrow, the curve could be wide. You know, that just has to do with how we educate people on planet Earth, and we don't do it evenly. And we notice the idiots more than the geniuses. It's because the geniuses aren't too busy, it does say art, with other things than making fools of themselves. Well, whatever. Says you, frankly. I mean, most of this stuff doesn't happen through big genius. It happens through little incremental steps at a time. Like I said, they gave the Nobel Prize for the blue LED to one guy, essentially, I think, or two. And, you know, it took 52. It took 172 people to do all these little advances that made it possible. So again, that's you're standing on the shoulders of minions. You're standing on the shoulders of, all kinds of stuff, okay, that makes the innovation possible. All right, so then we're back to the Puro crap. I don't know if I ever even read the bro answer, but it was not really an answer. He didn't get to, it's just full of his extra crap that, endless tripe. Okay, missing the subject. Yeah, so there's nothing else here. Yes, I've always wanted to build horn speakers with long exponential horns. This is an audio independence transformer analog. So that's on the subject of 2 voltages in the same place, I think. All right. Oh, this kid's video was just terrible. Yeah, I'd seen that one before. They're just unwatchable. They have to do everything's a gimmick. So they make a big giant catapult or a big giant something. And, all this, we have to make it giant and it's fun. No, it's stupid. All right. Yeah. So I think that's all we got. Just so this isn't going to do, right? I mean, this is too little interaction to provoke any, the whole point, which is to, the point that's missing, in exactly the 1700s when it came to arguing kinetic energy. There were just 2 camps, and the camps just never really dealt with each other's arguments. They just kept making their argument, and they just kept ignoring the other argument. And so the 2 things, there was never a test. There was never a demand that the conflicts be resolved. And so over time, they just accepted one theory, but it was never really tested. It was never had to go through the gauntlet of surviving, counter arguments that were relevant, because both sides were just propagandists. Both sides were narrowing the field of view just to their argument, and that's not good science. But anyway, so I am interested in any kind of evidence, any kind of reasoning that in some way explains why something I'm saying just can't be true, blah, 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 blah. So we're still looking for something to convince the naysayers regarding the whole kinetic energy crap, that the bullet actually takes 2,000 joules of energy to shoot. That's true somewhere when it isn't true. And the bowling ball going 1 mile an hour is, in the case of a real .22 slug, it probably could be going 2 miles an hour. Does have just as much energy. It will move just as many molecules. So if you just counted it based on how many molecules it moved, they'll both move the same number of molecules. So if you just find a test where you can compare both of them equally, that's a fair test. At a fair test, they both have the same energy. They can, run the same distance around a track, however you want to look at it. One will do it just much faster than the other. Anyway, so we'll call it a video. What the hell? Like I said, until the environment of reasonable interaction improves, there's not much you can do. Like I said, I post this stuff on Quora, I get 4 idiotic answers, and you're just like, well, what's ask a simple question, get a bunch of evasion. So you can't do much unless you have the counter argument, and then even when you do, and you mock it and you point out how your counter argument sucks, they take no responsibility for the sucky argument. Like Puro, he'll just say, well, the same spring compression creates different momentums. They'll just keep saying it, even though the evidence demonstrates that that's not true. They'll just keep saying it. So, can't reason with that. All right, so this has been, just keep it short, a draft physics video presentation. Thanks for your attention and such, but yeah, there's not going to be any action until we have the necessary reaction, right? The environment has to do something. In this case, the environment doesn't do anything. There's just no possibility of fixing anything or changing anything. If the environment's going to keep running away, can't do much. All right, I could add a little bit. Yeah, I could do that. I didn't finish Jerry's comment yesterday, but it's not really any physics. So he says, as humans, we are bugs living on a tiny rock under special circumstances. Well, they're only special to us. I would argue that the circumstance of being alive is rather unique in the universe, but regardless. Without friction, air resistance, gravity, and steady soil under our feet, it can be difficult to understand what's going on. See, I don't think any of that's at all difficult. They could draw these little spaceship pictures when I was in grammar school, and I could get it. So, it's not that hard to imagine. Not for you maybe, but for the rest of us. Again, you're making excuses. You're just belligerently arguing that the science can't be wrong. Okay, you just have such confidence that they went to school for a good reason and they learned something sensible, and you're just resisting. Like I said, and it's a tiny change I'm making, right? The third law change is, you can sort of understand. It's not so much, about the environment caring about what you're doing to it and then doing something back at you. It's about the fact that you did something. It's about you. If you're donating your money, it's not about the fact that, I donated my money, I fixed the world, and now the world praises me or something. What's going to make you move is the fact that you gave away something, not that you're going to get something back, not that you're going to get a reaction. So it's kind of wrong to say action, reaction. The action of giving away your money is what made you poor. You didn't get poor because of the reaction from the world. You got poor because you gave away your money. Not to dissuade people from giving away their money, wink, wink, but it makes you poor. I should make a video someday, so that's the part I missed. Yes, well, if you do, let me know, because I do have you blocked, and I'm not going to know anything about it, so... yes, somebody should make a video. That would be a great idea, to have other people make videos making assertions, and they just can't be such wimpy little pussies that they get all butthurt if somebody says, well, that's shit, man, and this experiment proves it's shit. It don't work. Where's your straight line in an ether? How do you create the geometry to make a straight line in an ether? If all of this stuff is doing all of this stretching and compressing, isn't it going this way all the time? And then isn't that something we should be able to detect? These are real, things you got to answer. You can't just run from them. But anyway, yes, it'd be good if you made videos, because I would certainly be entertained. Because your physics sucks, it's just a fact. The physics, the standard model physics, is crap. And it's rotten from the core. I mean, I thought it was just a little bit buggy, but no, it's just brown fungus now. The whole thing is brown fungus. And you can just see it in everything they do now. It's so obtuse, so disconnected, the muons say, they don't even know what a muon is. So anyway, enough. I would argue it's 2 electrons. So the 2 electrons are drafting, essentially. So they're going through space, assisting each other. And they get further and further apart as they slow down. And that's why they poof. And they say it creates a photon through a simulator, but right, what's a simulator, right? So that sort of you know, the electron is obviously creating electricity in the simulator, and the simulator is creating the photon. So that's kind of obvious. The muons themselves are not creating any photons. Anyway, but that's a whole another subject, right? Yeah, it's pretty much another subject. All right, so now I'll be done. All right, so till the next time and such and so forth and whatnot. Yeah, it is discouraging. I mean, it's got to say, it's. I mean, if I just look back at the the last 5 months on this one subject, and I just can't. I'm not gaining any ground, and these arguments are indestructible. I mean, it was absolutely silly for physics girl to say I 100% transferred the momentum, yet I lost half the energy. I mean, it's as ludicrous as saying I poured 100% of the paint in the bucket and I spilled half of it. I mean, it's that bad. And there's no counter argument to the fact that that analogy holds. If momentum means something, you can't conserve the momentum and then make some claim that, oh no, but half the energy's gone. What are you talking about? How is that possible? How can momentum mean anything? Well, I'm getting answers. Alright, so till the next time and such and so forth and whatnot. This has been a DraftScience video presentation.